Welcome to the Amp-322 how-to video for the Common Collector and Darlington Circuits Lab. Okay, let's test the circuit. So this guy is a common collector circuit, so it's going to be a current amplifier, and our signals in and out should be in phase. So let's see if that's the case. Take a look at our input and our output, and let's start it and see what we get. So there's our half volt peak to peak, and let's turn on blue, and let's keep them together here. And you see they're in phase and the voltage gain is 1. And what we have here is we need to compare this current with this current. So we have very large resistance over here, and we have to use our parallel formulas in order to do that. And our output on this one. So we're going to do our calculations to figure out what our current gain is, because our voltage gain is just 1. Okay, since our formula is in RMS, I have added our DMMs, which under AC will measure RMS. And we have to do some calculations here. And let's get it started. So we got 164, 175. So let's, we need to do parallel of 22 and 27, and I did the calculation on that. It's 12.1 k ohms. And we're going to divide our VN, which is 176 second EE minus 3 divided by our 12.1 second EE to the 3, and I come up with 14.5. Let's go ahead and write that down. So we have 14.5 microamps. Okay. And this side is going to be these two in parallel, which is half of a k ohm. And we're going to divide that 164.4 second EE to the minus 3 divided by 0.5 second EE to the 3, and I come up with 328 micro. So let's place that. .8 microamps. Okay, good. So let's divide our 14.5 and our 328. And I come up with a gain of 22, current gain. .7, which is so let's add current gain to that because that's what it is. So we have a voltage gain of 1 and a current gain of 27. Okay, let's grab our meters here. Fix the circuit first. So we're going to want AC, in and out. And let's just grab a simple scope here. And I just want to check see if our signal is in phase or not. Okay, channel B, DC, let's do the same, 200 millivolts. And let's shut this down so that we could have a different color. So let's make the input color, we'll make it yellow. Okay, so they're in sync, and again we have a gain of 1. Okay, let's check our voltages. And we have 11 going in and 14, 12, 14. Yeah, they're about the same now. They're bouncing around, but yeah, we're at the same voltage in and out. Okay, we've looked at the AC voltage coming in and out, and we utilize our formula of VN RMS divided by the parallel value of R1 and R2, and that's going to get us 29.1 microamps. And we use the output voltage divided by 25, and that gives us 13.1 milliamps. So our gain is going to be 450. So these are very high current gain devices. Okay, let's bring out our scope, and we're going to need 3 inputs. And of course we're going to need our ground. Okay, so we're going to use yellow as our input signal. We're going to use blue as our common collector, and we're going to use this guy for our common emitter. So let's start it and see what we're going to get. Okay, 200 millivolts per division. That looks good. Let's turn on blue. That's 1 volt. Let's see if we 200. Good. That's a gain of 1. And let's turn on our cyan, and that's 1 volt. So let's make it 200 also, and see if we can keep it on the screen. Good. So what we're showing here is, okay, we have because this is the emitter, this would be a common collector, and we're going to get a gain of 1 voltage. So and he is going to second, which is blue. And let's turn off this one. So out of phase, common emitter. Okay, here's the emitter, so this is the common collector, so let's turn him on and turn the other one off. And you see the common collector is in phase and a gain of 1, and this was designed to get gain of 1 on both of them. It just is to demonstrate that one of these is out of phase and the other one's in phase.